as our fine-tuned model is performing well, it is time for us to create a simple web interface where we can upload these invoices and see the extracted output. For this task, let's quickly think through what are the different steps that we need to perform. The first step is create a simple web interface. Right? Once we have the web interface, our current prediction pipeline expects the image path, and hence we need to save the image. Once we save this image, we can use the existing prompt, and if we remember, we created a method which will create a VLLM prompt for us. Once we pass in the existing prompt and the image path, create VLLM prompt. And then once we have the VLLM prompt, we have to initialize the LLM and initialize the sampling parameters. We need to perform prediction and then extract the output and return the text, right? So we need to perform 8 different steps. However, majority of these steps are already available as part of our code. So let's quickly run through each step and create an end-to-end inference pipeline. Okay, the first step is to create a simple web interface. For this, we are going to use the grad.io module. If you don't have grad.io installed, make sure to run this quick install grad.io code. And then I have created a very simple web interface where we have 2 different panes. The left pane, user is going to upload the image. On the right pane, we are going to extract and show the results. And we have 2 buttons. One is the reset button. Next one is the submit button. When user hits the reset button, it resets the UI. And this, when user hits the submit button after uploading an image, is going to invoke a method named invoice parser. So let's go ahead and create this method. Define invoice parser. And user is going to upload an image, and here we have the image as an argument. Now we have to perform this series of steps to extract the output, but to test this UI, let's create a dummy string and then ID colon 1 2 3 4 5. And just return this dummy string for now. Okay, so the expectation is on the first step, once we run this code and upload an image, it has to return this string in the right side. Let's run this code. Okay, since we have given share equals to 2, it has created a public URL. Let's click on this URL. Let's wait for UI to be loaded. Okay, so this is our left pane where we are going to upload the image, and this is going to be the right pane where we are going to show the extracted data. So let's click on this. I'm just going to choose one image from the test set. So this is the first image. The image is loaded here. We are seeing that it has one menu item. Let's just hit on submit and see if we are seeing the dummy string on the right side. Yes, here we are seeing the dummy string. So the UI is working perfectly. Let's go ahead and work on the logic for extracting this information and showing it in the web end. The next step is to remove this dummy string, right? And given an image, we have to save this image. When the user is passing this image from the front end, we are going to receive it as PAL image, and hence the image path for us, the place where we have to save this image. Let's create directory for now. Ways that if not of ways that make direct, sorry, ways that that exists of inference. We don't have the ways that make directory of inference. Here is the inference directory. Now the image path is going to be post.path the join, say inference directory, and then test image.png. For now, I'm just keeping the same name, but if we are going to do it for multiple users, we have to add some kind of unique identification here. But for now, I'm just going to keep it like this. Now, we have to save this image. Since it's already a PL image, all we have to do is image.save of image path, right? So step 2 is done, saving the image. Now step 3 is to use the existing prompt. So this is the prompt we use for fine tuning. Paste the prompt which we use for fine tuning. Okay, this is the prompt. Now we have the prompt and we have the image path. All we have to do is create VLLM messages, and it takes 2 arguments. One is the image path and next one is the prompt, right? So this is going to return the VLLM prompt for us. So this is the step number 4. So we have saved the image, we have copied the existing prompt, we have created the VLLM output. The next step is to initialize the LLM and the sampling parameters. Let's paste the LLM. This is the part where we load the model. We have to do it only once. And then this is the part where we set the sampling parameters. Let's run this. This is going to be the sampling parameters. Now we have the VLLM prompt. We have the LLM and the sampling params and the message. Let's go ahead and do the prediction. Our prediction will be LLM.generate, and we have to pass in the message, which is the VLLM prompt, and here we have to pass in the sampling parameters, which is going to specify the temperature and number of tokens to output. This is going to be our prediction, right? And once we have the prediction, we have to extract the output as well. Since we have provided it as a list, we have to return prediction of 0 dot outputs of 0 dot text, right? Now we have done all the 8 steps specified in this inference pipeline. Let's go ahead and run this. Okay, we run the code now. Okay, let's click on this URL. Wait for the UI to get loaded. Okay, we have the UI. Now let's click on drop image. Select the first image which we selected earlier. So we have the one single item, and we have the subtotal and the total. Let's go ahead and click on submit and wait for the results. Okay, the inference took around 4 seconds, and let's check the output. So we have the menu, we have, okay, the menu item and the price. Subtotal is going to be 11, yes, and the total price is going to be 11 as well. Nice. So the predictions looks good. Now let's try another image. This one. Okay, here again we have one item, and the item count is here. This is going to be the price. This is the tax or something, and then you have the total. So let's go ahead and click on submit and see what is the output. 4.4 seconds. Nice. Okay, here we go. We have the name, okay, matches, and then the price, which is 28,182, good, and the count is going to be 1. Again, the count was in different line. Our model was able to pick it. That's good. And then the subtotal is 28,182. The tax price is 2.818. Here we can see, and the total cash is 31. Looks to be really good. Let's try one last image. This one. Okay, here we have multiple line items, and we have the subtotal, and we have the total as well. Let's just hit submit and see how well it is. Okay, in case of multiple totals, it's taking around 5 seconds, around 6 seconds here. Okay, now, yeah, the result is really good. The reason being, these two are considered submenu. I'm not sure if it is same with the ground truth, but Here we can see we have the main menu with the amount, and there are two sub menus with the count and the price set to 0, and the subtotal is 45455, and there is a tax 4545, and the overall total price is 50,000. So as we can see, the results are comparatively really good. Maybe we have tested with more invoices and even complex invoices where there is lack of clarity and there are like multiple different inputs. However, we were able to successfully build an end-to-end invoice extraction pipeline with the fine-tuned model.